Hello dear student, how are you? I hope you are all will be fine. I am also fine, thank you. Welcome to your channel, that is Acid Science Group. Let's start the topic. And if you remember, in previous lecture I explained you the liquid HF and I also explained the auto-ionization of HF, liquid HF. But in today's lecture I will be discuss the behavior of various compounds in HF solvents, behavior of various inorganic compound like that is sulfuric acid, that is citric acid, that is nitric acid, that is perchloric acid. What will be the effect of HF on these what will be the effect of these acids on the HF solvents? So let's start the topic. According to auto-ionization, if you remember, I explained you in previous lecture, the auto-ionization of HF is shown in previous lecture that any substance that gives H2F ion, the auto-ionization of HF, the final reaction of HF will be, auto-ionization of HF will be HF plus HF. It will be generate into H2F plus F negative. This will be cation, this will be anion. So HF, the auto-ionization of HF that gives cations, all those substances in liquid HF, that give cations, cation, it will be behaves in an acid in this solid, and the substance that furnishes anions F negative or HF2 negative ions act. These all substances will be act as a base in this solvents. This point would be more clear from the following examples. For example, citric acid CH3COOH. Let to change the marker. Citric acid CH3COOH. Citric acid, we know that it is weak acid. It is one organic weak organic acid. That is weak organic acid in water. It is weak organic acid in water that act as a base in liquid HF. But this is inorganic, that is weak acid in water, but in HF solvents, but in liquid HF or HF solvents, it will be act as a base. This solvent, this CH3COOH, that will be act as a base in liquid HF. Yeah, this is the effect of liquid HF. This is the effect of solvent HF. And why this will be liquid, why this substance will be base in liquid HF? Because when you see the reaction, you will be cleared. CH3COOH, that is base. Let's remove first. CH3COOH plus HF in HF solvents. HF will be act as a solvent. When you add CH3COOH and HF solvents, when they are dissolved, it will give us CH3COOH2 plus F negative. That is solvent ions, according to auto-ionization of solvent anions. According to auto-ionization of HF, like here, this is HF. So according to the acid base concept, according to the solvent concepts of acid and base, all those substances that give anion of the auto-ionization, anion of the liquid, anion of the solvent, it will be considered as a base, while all those substances that give us, that furnishes cation of the liquid, cation of the solvent, like here in HF2, H2F plus, that is cations. So all those substances that furnishes cations of the liquid, that was prepared by, that was produced by, that was synthesized by the auto-ionization process. So this substance will be called acids. But here in citric acid producer, when you add citric acid and HF solvents, it furnishes the solvent anions, so that why they will be called, citric acid will be called base. And we know that it is clear cut that weak water is, citric acid is weak acid in water, but in HF solvents it will be act as a base. It will be the behavior of citric acid will be basic. This is the property of the HF. The another example of HF is H2SO4. Sulfuric acid. We know that the sulfuric acid are stronger acid, very strong acid. Similarly, HNO3 is also very strong acid, HNO3. Let's do first H2SO4. H2SO4, these are very strong acid, very strong inorganic acid, very strong acid, very strong inorganic acids in water solution, in water solvents. We know that it is very stronger acid in water solvents, but here in HF solvents, the behavior will be completely different. In HF solvents, it will show basic character. This is the unique characteristics of HF solvents. For example, H2SO4, when you add H2SO4 sulfuric acid in HF solvents, when you add sulfuric acid in HF solvents, it will give us H3SO4 plus F negative, and according to solvent concepts of acid and bases, those substances that furnishes anions of the solvents, it will be considered as base. Here we see that we are saying that H2SO4 furnishes anions of the solvents that was produced by the auto-ionization of the solvents. So that's why H2SO4 will be considered as base in HF solvents, but it is in water, in aqueous solvents, it will be show stronger acid. It is very strong inorganic acid. I hope this point will be cleared. Similarly, for HNO3 is like H2SO4. It is also very strong acid, very strong acid in organics, in water, very strong inorganic acids in water. We know that it is very strong acid in water, but it will be considered, but in aqueous, in HF solvents, it will show basic character. Why it will show basic character? Because when you add HNO3 to the HF solvents, that is HF is solvents, when you add HNO3 to HF solvents, it will produce H2NO3 plus HF plus F negative. Means the HNO3 or H2SO4 or C3COOH, these all are the proton acceptor in HF solvents. Actually these all are the acids. HNO3, H2SO4, C3COOH in aqueous solvent, it will give water, it will give hydrogen ion in aqueous solution in water, but here in HF solvent it will have characteristic, it will have the property of the accepting proton. So that's why in the result they will furnishes the anion of the solvents that was produced by the auto-ionization of solvents. So according to solvent concepts of acid and base, HNO3, according to solvent concepts of acid and base, those species, those substance that give us, that furnishes the anion of the solvent, it will be act as a base. So HNO3 will be considered as base. These all are the characteristics or properties of the HF solvents. I hope this point will be clear. Let's do another unique example. Now I am cleaning the board to proceed the topic. You can take screenshot or you can rewind the video. Okay, thank you. Yeah, one another example. That is HClO4. HClO4 perchloric acid. It is very stronger acid in water. It is perchloric acid or HClO4. It is very strong acid in water. A very strong inorganic acid in water. Means it will give proton in water. In the result, it will increase the proton concentration, the hydrogen ion concentration in the solution. But here in case of liquid ammonia, in liquid HF, in liquid HF it will act as a, in liquid HF, HClO4 will be act as a amphoteric, act as an amphoteric substance. It will be act as an amphoteric substance. Why it will be act as an amphoteric substance? Because in liquid HF it produces the ions of both the ions of this solvents, that is anion is and cation that was produced by the auto-ionization. It will produce both these ions. For example, when you add HClO4 in water, HClO4 in HF, it will produce it can produce H2ClO4 plus F negative. F negative, it is the anion of the solvents that was produced by the auto-ionization. Similarly, at the same time, in the same solution, HClO4 can also have the donating property of proton. HClO4 have also the accepting property of proton, and it has also the donating property of the proton in HF solvents, and it will produce ClO4 negative plus H2F positive. So that is the cations of the solvent that was produced by the auto-ionization of the HF solvents. So in the solution, in the result of the solution, both the ions, that is anion of the solvent and cation of the solvent, are synthesized or furnished. So that's why they are called, according to solvent concepts of acid and base, those species that furnishes cation will be act as an acids, and those species that furnishes anions in the solution, it will be act as a base, anion of the solvent, cation of the solvents. So that's why here at HClO4 and HF solvent it produce both the ions, so that's why they will be considered as amphoteric substance. This was the property of HF that completely changes that have complete change the characteristic from water, because in all these acids in water have the characteristic only to donate, only to lost the proton, while in case of HF solvents, some of the acids have the characteristic to accept proton, while HCl4 have also it have the property to accept proton as well as to donate proton, means it is amphoteric, but in water it is very, very strong acid though. I hope this point will be cleared. Let's go to the another examples. That is electron acceptor fluorides. Electron acceptor fluorides. Electron acceptor, for example, that is BF3, ASF3, PF3 and SBF5. These all are accepting of electron. They all have the property of accepting of electron because it have the deficiency of electron. These are electron deficient compounds. So they have the property to accept electrons. So come to the point. So when you add BF3 and liquid HF, when you add BF3 and liquid HF, it will produce H2F positive plus BF4 negative, means this BF3 will be accept one electron pair from the HF. It will be accept one electron pair from the HF. So that's why HF will get positive charge. That's why HF will get positive charge. शायद शायर ना गलत शाल सही दुकान सारी. Okay, come to the example. When you add BF3 and HF solvents, it will produce BH2F plus BF4 negative. BF4 negative means this one fluorine will be accepted by BF3 because BF3 has one vacant orbital, so that's why they can accept one fluorine. So as a fluorine will be as a fluoride, BF3 will be accept fluorine as a fluoride, so that's why H2F will be get positive charge and BF4 will be get negative charge, because electron pair will be shifted with fluorine toward BF3. So that's why HF will be get positive charge. And this is also the cation of the solvents that was produced by the auto-ionization or self-ionization of the HF solvents. And this is the anion in this solution. And we know that all those subspecies according to acid-base concepts, solvent concepts of acid and base according to, so all those species, all those substances that furnishes cations of the solvents will be act as in acids. So here BF3, it will be act as an acid, it will have acidic property. Is that clear? Similarly, for another example, that is SBF5. SBF5, when you add 2HF to HF, when you add SBF5 in HF solvents, it will produce H2F plus SBF6 negative. So this is also the cations of the solvents. So according to the solvent concepts of acid and base, SbF5 will be act as an acid. So these are the general characteristic of the HF solvents. I hope these all are will be cleared. Still, if you have any confusion, if you have any question in any points in any topic, whatever in chemistry, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in description box. You can get from there. Okay, thank you very much. And next lecture I will be explain you the chemical reaction taking place in HF solvents. All those chemical reactions that taking in HF solvents will be explained in the next lecture. Okay, thank you very much. Very best of luck, medicine. Very best of luck.